This is the third video on quadratics, and it concerns the quadratic formula and the discriminant. Okay, so we're going to start by using the quadratic formula to solve three different equations. Now normally if you have quadratic equations to solve, the first thing you try to do is to say, well, do any of them factorize, because that's the quickest method. But in this case we're going to use the quadratic formula on all of them, whether they factorize or not. So let's have a look at the first one. 2x squared minus x minus 3 equals 0. We can use the quadratic formula, and that means if you've got ax squared plus bx plus c is 0, then x is equal to minus b plus or minus the square root of b squared minus 4ac over 2a, and you need to learn this formula. Right, first one. Let's find a, b and c, and we've got to be careful with the signs. A is the coefficient of x squared, and that is 2. B is the coefficient of x, and that is equal to minus 1. And c is the constant term, and that is minus 3. Now let's work out what x is. So the way I always do this is I work out my minus b, my b squared, my 4ac, and my 2a, and just slot them in. So minus b is minus 1, that's plus 1. B squared, well, when you square minus 1, a minus times minus becomes a plus, so that'll be plus 1. 4ac will be 4 times 2 times minus 3, which will be 8 times minus 3 minus 24, and 2a will be 4. So I get 1 for minus b. Plus or minus, square root, b squared, minus 1 times itself, plus 1. I leave the minus sign there. Then I do 4 times 2 times minus 3, 4 times 2 is 8 times minus 3, minus 24, and I write minus 24 down. Now the reason I do it that way is you've got to be very careful on the signs here, and so because I work out the 4ac separately, I now can look at it and say, it's minus minus, it's going to make a plus, so I'm going to get square root of 1 plus 24, square root of 25. If you try and do too much at once, it's very easy to go wrong on your signs. So now, having got this, I do 1 plus 24, because minus minus is plus is 25. Then I can square root my 25 to get 5. Well, 1 plus 5 over 4 is 6 over 4. Or it's 1 minus 5 over 4, 1 minus 5 minus 4 all over 4. 6 over 4 cancels to 3 over 2. Minus 4 over 4 is minus 1. So we've got two solutions, 3 over 2 and minus 1. Okay, so x could be either of those numbers. Next one, 4x squared plus 20x plus 25 is 0. Right, this time a, b and c are really easy. A is 4, b is 20, c is 25. X is equal to minus b minus 20. B squared, 20 times itself, is 400. 4ac, 4 times 4 times 25, well 4 times 25 is 100, so 4 times 4 times 25 is 400. 2a, 2 4s are 8. Now notice, this time the part in the square root is 400 minus 400, so that goes to 0, so you're going to be left with minus 20 plus or minus 0 over 8. Well, adding or taking away 0 has no effect, so you're left with minus 20 over 8. Just for one solution, let's cancel it by 4 though to get minus 5 over 2. Third one, x squared plus 2x plus 3 is equal to 0. Okay, this time the a, b and c are so easy I'm not even going to write them down. A is 1, b is 2, c is 3. But be very careful with our signs when we work out the next bit. Minus b is minus 2. B squared is equal to 2 squared 4. And then take away 4ac is 4 times 1 times 3, 12. And then 2a will be 2. So you're left inside your square root with 4 minus 12, which is minus 8. So you get minus 2 plus or minus square root of minus 8 over 2. Well, when we're dealing with real numbers, there is no solution to square root of minus 8, so this has got no real solutions. Okay, if you do complex numbers at any stage, then we do actually find some solutions to that, but for real numbers we get no solutions here because it's square root of minus 8. Now, something really important now, which is going to bring us on to the discriminant. The discriminant is b squared minus 4ac. Now notice here, The discriminant this time is b squared minus 4ac is a bit in the brackets. Sorry, inside the square root. The bit in the square root here was 25, a positive number, and notice we got two solutions. The bit inside here, inside the square root, came to 0, and we only got the one solution. What we normally say there is we're going to talk about it as having two identical real roots, whereas this one having two different real roots. And then the final one, when you have square root of a negative number, there were no real solutions. And so this part inside the square root, the b squared minus 4ac, will tell you how many solutions there are. So if it's a positive number, we get what are called two different or two distinct real roots. If it equals 0, we get what we say as two identical square roots. And if it's less than 0, you get no real roots. Let's look at that on the next page. Discriminant b squared minus 4ac, and these were the rules I just said. If b squared minus 4ac is positive, if it's more than 0, they are two distinct, that means different real roots. You need to know both words, distinct or different. Okay. B squared minus 4ac equals 0, there are two identical real roots. It's like when you get one solution, two identical real roots. B squared minus 4ac less than 0, there are no real roots. Okay, now we can combine these top two by saying that if b squared minus 4ac is greater than or equal to 0, so if we don't know which of those happens, it could be greater than or equal to, then we know that there will be two real roots, but we won't know whether those roots are distinct or identical. Right, let's look at the graphs of the three equations that we looked at earlier. So we're going to look at y equals 2x squared minus x minus 3, y equals 4x squared plus 20x plus 25, and y equals x squared plus 2x plus 3. And here are the three graphs. The first graph, y equals 2x squared minus x minus 3, and notice our roots are where it cuts the x-axis, because we solved 2x squared minus x minus 3 equals 0, we got two solutions. We got minus 1, we got 3 over 2, which is 1.5. So for this one here, we got two solutions. For the next one, that was where we only got a solution of when we put y equals 0, in other words, the x-axis is where y is 0, you had 4x squared plus 20x plus 25 equals 0. We only had the one solution, minus 5 over 2, or minus 2.5, and that's what we say when we say two identical real roots. It's as if you've got two that were very, very close to each other, and then you actually are moving your graph so that it was starting off with two real roots, and you move it up, and so it's just touching at one point. It's like those two real roots coinciding, okay? So we get two identical or two coinciding real roots. And then the third one, that's where we had square root of minus 8, and that had no real roots, no solutions. Notice it doesn't cut the x-axis at all. Let's look at b squared minus 4ac to remind ourselves. This was what we got inside the square roots on the previous page. When we did this bit, the b squared minus 4ac was 1 take away minus 24, and so that became plus 25, which was greater than 0. For this one, this was where we got the 400 minus 400, so it equals 0. And for this one, this was where we got 4 minus 12 minus 8, so it was less than 0. So for the first graph, notice we're getting greater than 0, so that means two distinct real roots. For the next one, equals 0, two identical real roots, less than 0, no real roots. Okay, let's do some questions. Firstly, solve 3x squared equals 4x plus 2 exactly, simplifying your answer. Now this question is an ideal one for using your quadratic formula. But first thing we need to do is rearrange it so it equals 0. So if we move a plus 4x and a plus 2 across to the left, they become minus 4x and minus 2. So you get 3x squared minus 4x minus 2 is 0. Now, you wouldn't be able to factorize this. And also, if you do completing the square instead to solve it, it's quite tricky because you've got a 3x squared involved there. So it's easiest to do this by the formula. So there's our formula. Let's slot everything in. A is the coefficient of x squared, it's 3. B is the coefficient of x, so it's minus 4. And C is minus 2. Put them in here, and you get x equals minus b, minus 4, 4, plus or minus square root of b squared. Well, minus 4 times minus 4 is plus 16. Leave a minus sign in there. And now for AC, 4 times 3 times minus 2. 4 times 3, 12 times minus 2 is minus 24. So you get 16 minus 24. 2a, 2 times 3, 6. Simplify the bit inside the square root. 16 minus 24, well, minus is a plus, so you get square root of 40 there. So you get 4 plus or minus root 40 over 6. And now we can simplify that out because 40 is 4 times 10, and 4 is a square number. So the square root of 4 times 10, or square root of 4 is 2, so that bit becomes 2 root 10. You notice it says simplifying our answer. So we can, instead of having root 40, we have 2 root 10 by splitting that into 4 times 10. Square root of 4 is 2. Now we can cancel. We can't cancel anything inside the square root with things that are outside, but we can cancel the other parts of that outside the square roots. And so you can cancel by 2, and you're left with 2 plus or minus root 10 over 3. 2 plus or minus root 10 over 3. Divided by 2, each of those numbers, but keeping it as root 10. Okay, next question. Find the discriminant for 4x minus 7 minus 2x squared equals 0. Hence find how often the graph y equals 4x minus 7 minus 2x squared cuts the x-axis. Okay, the discriminant, b squared minus 4ac. Be really careful. It's not the order the numbers are written down. A is the coefficient of x squared, so a is minus 2. B is 4 because it's 4x. And c is minus 7. Now we can work out b squared minus 4ac as b squared, 4 4s, 16. 4ac, 4 times minus 2 times minus 7 becomes plus 56. You're doing minus 4ac, so you're taking away 56. Notice we've got to be really careful on the signs here, because in effect the minus sign's kicking in 3 times. You've got a minus sign there, times 4 times minus 2 times minus 7. So that's why you're getting a minus 56 at the end, because you're getting a minus there, and the 4 times minus 2 times minus 7, minus sign again twice. So you're getting minus 4 times minus 2 is minus 8, times minus 7 is plus 56, and you're taking away the 56. I'm really emphasizing this because the signs here are critically important. Then 16 minus 56 is minus 40, so our discriminant is minus 40. Next, how many times will this graph cut the x-axis? Well, you can say straight away, b squared minus 4ac, it's minus 40, so it's negative. So it's no real roots, and if it's no real roots, then the graph of y equals 4x minus 7 minus 2x squared doesn't cut the x-axis at all. It does not cut the x-axis. Next one. The equation x squared minus k plus 2 lots of x plus 4k equals 7 has 2 identical real roots. Find the possible values of k. Now k in here is a constant term, but we don't know what it is. So k is just a number. So for instance, if k happened to be equal to 9, then k plus 2 would be 11. If you have minus 11x in here, 4k would be 36. And so k is just a number. But we've got to work out what it can be, given that this equation has 2 identical real roots. And as soon as you see 2 identical real roots, we say to ourselves, well, that means b squared minus 4ac must equal 0. So we're going to be using b squared minus 4ac. So let's work it out. But the first thing we have to do is we want this to be a quadratic equation equals 0. So the first thing, rearrange to make the equation equal 0. So bring that 7 across and make it minus 7. Now you'll notice I'm putting the 4k minus 7 in brackets here. They don't need brackets, but it's because when I'm working out my A, B, and C, I've got to realise my constant term is 4k minus 7. It's the whole thing there. Okay, so now let's find b squared minus 4ac, but let's do it really carefully because it is quite hard to find. First, A, B, and C. A is 1, that's easy. B, you involve a sign minus brackets k plus 2. And C is my 4k plus 7. That's why I put the brackets around it, so I realised that C was the whole thing. Now, I'm going to work out b squared and 4ac separately, because if I try and do it all in one go, it's too easy to make a mistake. So let's do b squared first of all, find what that is squared. Now, be careful. When we're squaring it, we're timesing it by itself. So you're going to be multiplying a minus by a minus to make which makes a plus. So in effect, what you're doing is doing minus k plus 2 multiplied by another minus k plus 2. Well, minus times a minus makes a plus, so you're left with k plus 2 times k plus 2. Let's expand it. K times k, k squared, 2k, another 2k is 4k, 2 times 2, 4. Okay, 4ac. 4 times 1 times 4k minus 7. 4 times 1 times 4k minus 7. Well, times 1 doesn't make any difference. You're left with 4 times 4k minus 7. 4 times 4k, 16k. 4 times minus 7, minus 28. So, we've got b squared there. We've got 4ac here. You want b squared minus 4ac. Be careful. This stays as b squared, but when you take away 4ac, you're going to take away both these bits. So you're going to do minus 16k and minus 28, which is plus 28. So b squared minus 4ac is k squared plus 4k plus 4 minus 16k minus 28 plus 28. So again, be careful on signs. Okay, let's simplify it. K squared, 4k minus 16k is minus 12k. 4 plus 28 is 32. So we've got b squared minus 4ac is k squared minus 12k plus 32. And we're told the equation has two identical real roots. Therefore, if it's two identical real roots, b squared minus 4ac is 0, so this must be 0. So k squared minus 12k plus 32 is 0. So we've got another quadratic to solve, but we can solve this one any way we like. And you could use a quadratic formula again if you really wanted to, but the first thing I always look for is factorization, and this one really factorizes nice and easily because 4 times 8 makes 32, and 4 plus 8 makes 12, and so when we factorize this one, you can factorize it to k minus 4 times k minus 8. Notice it's k, it's not x, because the equation's in terms of k. And just check it, k squared minus 8k minus 4k is minus 12k, minus 4 times minus 8 is plus 32. So k minus 4 times k minus 8 is 0. That means either k minus 4 is 0, which gives you k as 4, or k minus 8 is 0, which gives you k as 8. So k is 4 or k is 8. If you wanted to, if we put k as 4 in here, you would get x squared minus 6x plus 16 equals 7. And you could try rearranging it and solving it, and you would find it had got only one solution, because if you tried solving that in, it is going to be one of those that only gives you one solution. If you put k equals 8 in here again, and you got x squared minus 10x plus 32 equals 7. You try solving that, obviously put it equals 0 first and then try solving it again, you'll find you only end up with one solution. So you could actually try and check that yourself, but you don't need to do that. We've got the solutions here. Okay, so good luck with these questions, and this type here are very, very common, so you do really need to learn how to do this type of question here. Okay, good luck.